forward. So I want to briefly talk about all of the various gas laws. I have some video demonstrations. This is normally where I do some of these demos in the lecture hall, and I love doing these demos, but I don't have access to a vacuum chamber or liquid nitrogen at my house, unfortunately. Okay? And after I summarize all of these gas laws, then that'll be the end of this first video. So the first one I want to talk about is Boyle's law, and you should be familiar with all of these laws by name and by their relation. Okay? So Boyle's law says that pressure and volume, so the pressure and volume of a gas sample are inversely proportional to each other. Okay? So this little crazy like fish looking thing, so this means proportional to. Okay? And so what that means, if we looked at a graph of pressure versus volume, and what's also important to note, this is at constant temperature. Okay? So assuming that we can hold the temperature of our gas sample fixed, like suppose it's a balloon filled with some air, if I decrease the pressure around the balloon, so in other words, if I decrease the pressure, notice what happens. The volume has to increase. Okay? But what if I increase the pressure surrounding the balloon? Like I squeeze the hell out of that balloon, right? Well, it's going to get smaller. Okay? And so that's what we see in this graph. That's what this relationship means. P is inversely proportional to 1 over V. Okay? Another thing we could do with this Boyle's law, we could do algebra with this. And if I multiply both sides by V, that cancels this V. And now I have PV. Okay? But in the same way with our dilution equation, right? P at condition 1 times V at condition 1 has to be P at condition 2 times V at condition 2. So in other words, if I have a balloon, let's say it's, rather small. Here's my balloon. And I've got P1 and V1. So I've got a volume of the balloon, and there's some pressure all around this balloon. Okay? Suppose now that P1 is less than P2. What's going to happen to the volume of this balloon? It's actually going to get bigger. It's going to get much bigger, depending on, of course, how different P2 is. And I've got a cool video of that to show you here. Let's see. It's hidden back here. And let's put it in the little view. Oh, you guys, this is so meta. I'm making a YouTube video
in a demonstration of Boyle's
while
law,
I'm playing you
we'll
YouTube
place
videos.
A balloon in a vacuum bell jar. We'll apply a vacuum, which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law,
the PEEP. This is the best chemistry demo ever.
Jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the PEEP will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another illustration of Boyle's law, we will put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
Okay, that was cool. I would not want to make my vacuum chamber all messy with shaving cream, but I'm glad that that person did it. Okay. Okay, so Boyle's law, P and V inversely proportional. If I squeeze on a sample of gas at constant temperature, its volume has to decrease. If I reduce the pressure around the volume at constant temperature, its volume has to increase. Okay? And really the reason for that, what's going on, is because there are also molecules in the balloon pushing the balloon out, right? So if this is like my P1 and this is my P2, eventually they want to have an equal force onto each other, right? This is related to Newton's second law. For every action, there's an equal and opposite reaction, okay? So this is why we see the balloon swelling or compressing depending on how the outside pressure changes, all right? So let's do a sample problem. So a balloon is filled with hydrogen at a pressure of 1.35 atmospheres and has a volume of 2.5 liters. If the temperature remains constant, what will the volume be when the pressure is increased to 2.5 atm? Okay, so we remember we're going to use this equation. P1V1 equals P2V2. It doesn't matter what I pick for 1 and 2 as long as it's consistent. And it's asking me for the volume, so then I'm going to say let's solve for V2. So I first like to do the algebra. And to isolate V2, I'm going to divide both sides by P2, okay, which will give me P1 times V1 divided by P2, and that all equals P2, okay? So now they tell me it's 1.35 atm, okay, times V1 is 2.54 liters, and then now what will the volume be when the pressure is increased to 2.5. Okay, so it's always good to kind of ask ourselves, do we expect the volume to get bigger or smaller? And if it's increasing the pressure or squeezing it, we're going to make it smaller. Okay, so let's do that simple math. 1.35 times 2.54 divided by 2.5, and with looks like 3 sig figs all around. Yep, it got smaller, 1.37 liters. Fantastic. Okay, let's move on.